Fantastic. And I think I'm going to start us off. Is that right, Linda? And just a shout out to Linda Hobbs, who's online, and Seamus Delaney, some of our team members for our project on out of field teaching. Our project is dealing with four subject areas: science, mathematics, English, and geography educators. But today we're going to be talking about the science aspect of it. So let's go to the next slide. Which is a broad acknowledgement to country, knowing that we are all coming from various different places, acknowledging the Indigenous knowledges that have preceded our classic, what we call Western-based knowledges. And just about a week ago, I think last Sunday, August 9th, was World Indigenous Day. And just I throw out that appreciation with my students this week to in the science context, knowing that there's increasing amount of collaboration between scientists and First Nations people, looking at, of course, from a science lens, the environment and how to work together so that we can sustain all of the life systems that, for ourselves and for future generations. So thank you everyone for attending and acknowledging any First Nations people that are here with us today. All right, so just next slide introduces you to our cast, our team of ARC researchers and research assistants that keep this project going. And we collectively do represent expertise in those four subject areas I mentioned and even more. So I think we're very fortunate to have that expertise and also sort of to share our own experiences. And when Linda and I did a presentation at the Science Ed conference, I think just a few weeks ago, I asked everyone if they ever taught out of field, like when they were a classroom teacher, and I think about 3/4 of the hands went up in the room. So I suspect a lot of people here have had that experience, that firsthand experience as well in the school setting. All right, to the next slide. So in Australia, the research on out of field teaching is, I guess, it's been fairly well established for the last 10 or 15 years. And it tends to focus on the teacher's experiences, but there's other aspects of the problems as well. This is a continuing to grow this research area. So part of the problem is that, yes, we do have an ongoing teacher shortage, but we've had a shortage for a long time. And the out of field teaching aspect has sort of become normalized. And of all the subjects we've mentioned, mathematics and technology have the most out-of-field teachers. And from the 2021 AITSL data, so that's AITSL is a governance, teacher standard governance in Australia. They're pointing to anywhere from 20 to 27% of science teachers teaching out of field in biology, chemistry, and physics. So about a quarter of the secondary teachers. And we know in terms of upskilling that different stakeholders across the system have had various offerings, but these tend to be sporadic, uncoordinated, not always available, and not in all subject areas. So the focus of our project is about what kinds of professional education opportunities are needed for out-of-field teachers. And when we say professional education, think professional learning plus mentorship, grad certification, and so on. All of those kinds of interactions that enable teachers to upskill and grow their confidence in a field that's outside their specialization. All right, so the next slide focuses on our methodology. So we're looking at, I guess, across the ecosystem, systemic factors that impact out-of-field teaching and how they can respecialize through professional education. So this ecological perspective, takes on, doesn't just, even though the teacher is at the center, there's sort of multiple layers of influences. And if we look at our research design, our methodology started off with a literature and policy review, and that informed all of our studies. And our first study was an interview study. This is some of the data that we'll be sharing today. We have our survey out now. It's an ongoing survey, and we'll actually share the QR code with you today for all the Australian educators in the house. And then the third and final study, which we are about to launch into, is a Delphi study and an Imagineering workshop. And so we're going to look at, from the data, we'll look at some of the solutions, and from sort of expert participants, we'll get them to inform those solutions as well. And yeah, I think we'll go on to, well, let's have a look at that interview study, a closer look at the interview study. So our interview participants are from 4 states in Australia: Queensland, New South Wales, Victoria, and Tasmania. And they all work in either policy context, so curriculum organizations, state, federal government, school authorities, including state, independent, and Catholic education, or they work in professional education contexts, such as higher education institutes, private professional learning providers, subject associations. And you'll see in that circle, we don't yet have school-based participants. We're close because of some of the challenges in getting State Department permissions. However, we will say that many of our interview participants have been teachers at one point in their career. So let's have a closer look at our participants. So we're going to be reporting on interviews of 9 participants that will speak to science. And as you can see on the, I guess, under representation, most are associated with universities or teacher associations. We have 1 representative from government. And we've pulled in quotes to give you a sense of their lived experiences. So some of these experiences are actually good, they're joyful, and some of them not so much. But they all sort of give us a sense of, you know, how these participants are understanding teaching out of field and what are the issues and possible solutions. And Linda, I think this is you.
Yeah, thank you. I thought that I would go a little bit into the Bronfenbrenner. So we are using Bronfenbrenner's ecological systems theory to look at the system. So this is why we spoke to people outside, not just teachers, but also people out across the system. So the way we're talking about this, we've got at the microsystem level is that immediate relationships that a teacher has within their school. The mesosystem is the interrelationship between those different microsystems. And at that exosystem level, you've got various organizations that provide professional education opportunities. It's also where policy sits. Sorry, the colors aren't great. At that macro system level, it's around those cultural values and beliefs that are informing the notions of specialization and decision making. And also at that chronosystem level, it's around those teacher workforce changes, career trajectories, those sort of things that occur over time and that have an influence further down into the system. So when we were looking at how to use that theory with our literature review, we could identify 3 different locations for learning. The first is initial teacher education that determines for teachers what is considered in-field and out-of-field. And that includes the study prior to initial teacher education as well. And then they move into that workplace, which, and in that workplace, there are various opportunities for school support. And then we've got the other location for learning is the professional education, which they might seek outside of the workplace, which would interact, of course, within the workplace in various ways. So that's we've talked about this in our latest publication as part of the special issue, which is describing those 3 different locations for learning. And so that's where we were beginning. And then what we're talking about here is the interviews from those, mainly from that exosystem space, but have been within that microsystem, as Connie was saying. So I'll hand back to you, Connie.
Thank you. And I think it's the following 4 slides. We're going to share some of the findings so far. So the first one is actually the language of out-of-field teaching. And on one hand, it's useful to say out of field teaching because people have an understanding of what that means, especially government, and it sort of points to what the challenges are. But on the other hand, it's not as useful, say, for teachers because there's, I guess, a notion of othering associated with it. So that's not always helpful when we look at the systemic nature of the problem. So there's a tension that comes out when you're identifying someone as an out of field teaching. And from the school perspective, it's actually just a very practical response to timetabling, for example. And yeah, I think the next slide will unpack the idea of subject specialization in science. So science is considered a multidisciplinary subject. The actual practice of science in real life probably has hundreds of different disciplines in a K to 12 construct. For example, in Australia, they've distilled it down to 4: biology, chemistry, physics, earth, and space science. So the nature of science in of itself is multidisciplinary. And here we have the idea of sort of near and far. So certain disciplines are more closely related than other disciplines. And if we look at it in that way, you might say, well, then all science teachers are likely to be out of field. And that is exactly what some of our participants were saying. So we see this, say, in the expectations of pre-service teachers who go into their first teaching assignment. I'm a physics teacher, but I'm teaching year 7 biology. And this is the same for those of us here that teach HAS or the arts-based English or humanities and arts subjects as well. You sort of get that same kind of dynamic. And then in another example, we had an interviewee that had a PhD in medicinal chemistry, but started off as an out-of-field physics teacher. And then we also had another participant talking about school physics actually being closer to university engineering than university physics. So there's a lot of complexities around the subject specialization. And so let's go. So that leads us to the idea that we need to get beyond the binary of out of field and in field, which leads us to the next slide of a continuum. So what if we change the language of out of field teaching to a continuum of out of field, rather than a binary? And what does qualification mean versus experience? And how is all that important for the notion of out of fieldness? So for example, one interviewee who had a PhD in chemistry and that ended up teaching physics is now seen as a physics expert. And she doesn't see herself as out of field at all. In fact, she talks about herself as if she's in field. So again, it's that individual perception of, out of field, even though we can put a label on someone else, it's actually how they feel is very important. That external validation. So we have a person that's been teaching physics for 20 years, but still does not see themselves as in field. So we sort of juxtapose those two examples. And then finally, there's an element of, I guess, a temporal nature of out of field, like, oh, I'm just filling in for this term, so we'll just get through this and move on. So I guess in summary, to summarize these ideas, so qualification matters for some people, but not for others. And that makes an interesting dynamic, which leads to that non-binary notion of out of field. The next slide looks at professional education. So what does all of this mean for professional education? Again, professional learning, mentorship, grad cert, and so on. So it means that we really can't have one size fits all. We can't have like one course that you teach to become in field in another subject area. Because we have this huge diversity. We've got people who are near out of field versus people who are far out of field, and the whole continuum in between. So our data is indicating a much more nuanced continuum rather than that simple binary. So we need to think about professional education in different ways. like we need to consider that it takes time for a newly appointed out of field teaching position to realize that, what they don't know, you don't know what you don't know until you start getting into it. And when they realize that, that's sort of almost an indicator that they're ready to learn. And we've listed on the right-hand side, I listed a few examples of different types of professional education that have been mentioned by our participants. So, of course, mentoring and just-in-time support in the schools, the importance of content and pedagogy. So each discipline, not just comparing science and English. I know Linda and a few other colleagues have put together a paper just comparing science and English, but even within the sciences themselves, that multidisciplinary nature of science, there's actually different pedagogies, different methodologies. You can imagine a biologist versus an astronomer. How do they go about their practice? So different methodologies. So it leads to different practices in the classroom as well. There's the assumption that there's only content knowledge needed, but that pedagogical knowledge is very important as well. And then there's important to acknowledge that there's limited access, and that there's other issues, which is the other issue we're finding. Schools are not giving teachers actually permission to engage in professional learning because they can't find a casual teacher, a casual replacement teacher due to the teacher shortage. So even if you were out of field and you were keen on learning, you may not get that permission from your school to engage in those opportunities. And then finally, as with everything, yes, there's constraints on time. And I think, it's over to you again, Linda.
Yeah, thanks, Connie. So what we're certainly hearing is a story of science as a subject, which is often captured in the out of field statistics, 20 to 25%. But if you actually start looking at the specialization and how people feel teaching different subjects, it comes back to a notion of out of fieldness. And so there's a component of needing to seek support in the same way that a teacher who is teaching out of field might need to seek support. I've never learnt physics in my life, and yet I had to teach it from year 7 to 10. So it's this notion of binary in field is sometimes not very helpful. And so it's shifting the language. What we're proposing is to shift the language to a spectrum of out of fieldness based on how close the area that's out of field is to the content that you're familiar with. So that comes down to teacher knowledge, what experience they've had, what confidence that they have, and we've talked about that a little bit today, what supports are available, and again, of course, that notion of passion and identity and how which is influencing the commitment that they have to the subject long term. So this highlights, therefore, the need for different language for different audiences and impact. And it was interesting that was brought out in the data was that one participant talked about it's useful to talk about out of field for policy because it highlights the problem as an issue that needs to be dealt with. However, when you start bringing it into the school or teacher space, that actually can invoke a sense of othering or outsider perception. And this came from somebody who felt particularly that they had gone from an out of field teacher and become an in-field teacher. And it was actually, it was not that they were an out of field teacher, but that they had to learn how to teach in a new context. So this brings up the question of why and when we use the language of out of field. And I know that that's been around for a while. And if I was to say that out of field language is not useful, then there goes my area of research. So it's useful, I think, to consider what we mean by out of field and the implication of using that in particular contexts. So while we did see negative consequences which come from the field, we also do see tales of changing identities, external affirmation, but this occurred only where teachers felt supported. So this raises again the importance of having that workplace focused support within the ecosystem, but also importance of getting access to professional development outside of the school. And so an important question for us going forward is how are schools managing this? And we're moving into that space as we continue to talk to schools and also get the surveys in. So we are aware, as Connie said, this is not just a science issue. This relates to all subjects, but particularly for those with multiple disciplines, where the humanities in particular, where you've got a banner of a subject that has multiple subjects in it. And when students are on placement or teachers are assigned their teaching, that they often pick up different subjects. Although science is a little bit different than the humanities, because you very rarely will you see biology in a Year 7 timetable, but you might see geography or history, for example. So yeah, there's a perception around science that it's perhaps more cohesive because of that inquiry, this notion of inquiry that underpins most subjects of science. So just conclusion then, how do we therefore conceive of support needs? If we think about this as a continuum, then that means that we need to have different sorts of support. It needs to be just in time, focused on the knowledge, teacher knowledge, but we also need that broader picture of what's going to be suitable for a particular subject. So, for example, some studies from some countries will talk about professional development for chemistry teachers who are learning to teach physics. You know, it's that fine-grained. In Australia, it's quite different because of this generalist approach to science. However, we do have subject specializations as associations. So Seamus, for example, is situated within a chemistry association, but also John is within the physics association, for example. So we do have that sort of support within the ecosystem to differentiate and focus on what's important for the particular science discipline. So this conceptualization therefore raises an important question for how we frame professional education for science teachers who might be more or less in field. And it also forces us to ask the question, should we actually expect teachers to become in field, or are we talking about more in field? And so I think it raises a question for everybody, regardless of context. What should be our goal here? Is it about supporting teachers to be just more in field, or should they become qualified and therefore considered technically in field? So this is our final slide. Sorry, I went a bit over. This is our survey. If you are interested, and it is an Australian survey, so apologies to our non-Australian colleagues. But yeah, all right, thank you.